nomenclature of the complexes, which is the most important part under coordination chemistry. Just like the IPAC nomenclature of organic compounds, here IPAC nomenclature of complexes are also very important. So how to start? From the previous discussions, review of the previous discussions, types of complexes, First,
Cationic.
anionic complexes. Anionic complexes means what? In this anionic complexes, what will be there?
Complexes we are negative
Complex
charge.
ion, anion. Complex ion,
Anion.
anion. And second part, required numbers of simple cations. Required numbers of simple cations.
Cations.
Required numbers of simple cations. Am I clear?
Yes.
No problem?
No.
Now, here, what will be the steps? First step, naming of simple cation. Naming of the
Simple cation.
simple cation. In order to name the simple cations, Saksham, there is no need of counting. When 4, 5, 3 simple cations are there, simply their names are written, no need of counting. Clear?
Yes.
So, no need of counting of simple cations. No need of counting of what? Simple cations. First scope is finished. Now, after naming the simple cation, directly, we should proceed to name the complex anion. Complex anion. Now, under this, what will be the steps? What are the steps towards this? What are the steps towards this? Okay? No problem?
No.
So, what are the steps? So, let us take up an example. We will discuss this by taking an example. Suppose the complex to be named is K4FeCN whole 6. K4FeCN whole 6. It is to be named. So now, post-mortem of this complex, you are knowing that what will be the first and foremost point of which will be utilized?
The bifurcation.
Bifurcation of the simple cation and complex anion. So here it is a molecular complex. Molecular complex consisting of cation and anion, not simply molecular. So 4K, it will be plus 4. Here minus 4, net charge 0. So first part is your 4K plus ion as simple cation. Let us take up this step by step in easiest way. Second part
is the complex anion.
Complex anion. Complex anion. And the complex anion is FeCN whole 6. 4 minus or minus 4?
Minus 4.
From the knowledge of the constitution of complexes or complex ions, section what you are knowing. So here in complex unit, one of the central neutral metal atom or cation is must. One central neutral metal atom or cation is must. Okay? It is the case of simple complexes. So here, now separation of the different parts of the complex unit. First of all, here selection of the central neutral metal atom or cation. What you are knowing in complexes, simple complexes, one and only one central neutral metal atom or cation remains. And rest will be your ligands. Identical or non-identical. Unidentate, monodentate, polydentate, as it will depend on numbers, will depend on the coordination number of the central neutral metal atom or cation. Here 6 cyanides are there. -4 is to be protected. So for 6 cyanide, net charge -6. So Fe will be
+2 oxidation state.
Okay. So central cation CC, Fe double plus. What about Fe double plus? What is the oxidation number?
2+.
2+. एकदम पोस्टमार्टम करते चलो. ऑक्सीडेशन नंबर ऑफ Fe double plus 2+. Coordination number of Fe double plus. What was told in discussion of Werner's coordination theory?
The two
Primary valency, that is oxidation number, can change, may vary.
But the secondary valency does not change.
Secondary valency does not change means coordination number remains fixed. Coordination number in any state is 6. Exception? What is the exception? Metal carbonates. Metal carbonyls. What is the respective metal carbonyl of iron? What is the formula? Metal carbonyl. FeCO whole 5.
FeCO whole 5.
Whole 5. Here, coordination number of Fe. So it is neutral 0, here 0. Is your 5.
5.
Khatam? Exception. So you decided the central cation and you are knowing oxidation number of Fe in this complex, not everywhere. In this particular complex is 2+. So coordination number is 6 irrespective of the variable oxidation states. Okay? Now, next part under the complex unit, 6Cn minus.
6Cn minus.
6Cn minus will be your ligands. Which is the donor here? Cn is here. Cyanide. Carbon
is the donor.
Carbon is the donor. It is what? Anionic unidentate ligand. Anionic unidentate ligand. This one is anionic unidentate ligand. And numbers are 6. So coordination number is satisfied. Coordination number is satisfied. Up to this stage, is there any problem? No? So now come to naming. So what is finalized? At first, we name the simple cation. Without any counting. Simple cation without any counting. No scope of counting is there. Now we will come to the second part. Second part means naming of the complex anion. And in complex anion, what is the split up? One is your central cation, that is Fe double plus, and 6 cyanides are as ligands. They are unidentate anionic ligands. So what is the rule? After giving the sufficient examples, we will summarize the rules. Here, after naming the central cation, because no scope of neutral atom will be there, because it is what? Anionic molecular ligand.
Molecular ligand.
Anionic molecular ligand means what? Simple cations must be there. So no scope of neutral atom will be there. Okay. So after this, what will be there? Ligands are named. Ligands are named in proper order. In proper order with क्या with?
With the numbers.
With suitable counting. Language बनाओ एकदम क्लियर होना चाहिए. With suitable counting. Clear? क्या हो गया? Ligands are named in proper order. Proper order कब? When different ligands are attached.
That is
When different ligands
are attached.
with क्या हो गया? Suitable counting. So now let us come to the next point, deviation from this main point, naming of the ligands. Unless and until you will not be more confident in naming of the ligands, the very purpose of IP nomenclature will fail. So now we have to name the different ligands. How to name? Pause करो.